second law explains what happens when there is a net force. The second law tells you how much change in motion results from any given net force acting on any known mass. The change in motion could be starting up, stopping, speeding up, slowing down, or changing direction. The second law relates force, mass, and the resulting change in motion. We know force is a push or pull measured in newtons. Mass is in kilograms or grams. But what exactly do we mean by a change in motion? The answer is acceleration. The second law tells us how much acceleration results when a force is applied to a given mass. But acceleration is a tricky idea. Here's a way to think about it. Imagine you compare the acceleration of a sports car and a delivery truck. The delivery truck goes from 0 to 60 miles per hour in 20 seconds. That means the speedometer increases by 60 divided by 20, or 3 miles per hour each second. 3 miles per hour per second would be the acceleration of the truck. Acceleration is the rate at which speed changes. On the other hand, the sports car goes from 0 to 60 miles per hour in only 3 seconds. The acceleration of the sports car is the change in speed divided by the change in time. The car changes its speed by 60 miles per hour in 3 seconds, so its acceleration is 20 miles per hour per second. Sure beats the delivery truck. Newton's second law relates acceleration to force and mass. In metric units, mass is in kilograms and force is in newtons. Acceleration then comes out in meters per second per second. An acceleration of 1 meter per second means the speed increases by 1 meter per second each second. The units are often written as meters per second squared, even though they really mean meters per second per second. Let's do an example. What happens when you increase the net force applied to a cart? Select different forces and be ready to answer a question when you are finished. Here is a question. What happened to the acceleration of the cart when you increased the force? A. The acceleration also increased. B. The acceleration decreased. C. The acceleration remained the same. Or D. There was no acceleration at all. So, when you increase the net force, the acceleration of the object will increase. This is a direct relationship. What happens if you increase the mass instead of the force? What effect will that have on acceleration? Now select different cart masses and see what happens to the cart's acceleration. Be ready to answer a question when you are finished. Here's a question. What happened to the acceleration of the cart when you increased the mass? A. The acceleration also increased. B. The acceleration decreased. C. The acceleration remained the same. Or D. There was no acceleration at all. So, when you increase the mass of the cart, the acceleration of the cart decreases. This is an inverse relationship. Now, let's put all this together. You can express Newton's second law of motion with a simple math formula. Acceleration equals force divided by mass. A equals F over m. The acceleration of an object is equal to the net force acting on the object divided by the object's mass. If I apply a net force of 100 newtons to a cart with a mass of 100 kilograms, the cart will speed up or accelerate at 1 meter per second per second.